All right, so here we are, outcome number 4. Let's go with part 2. So we've already done molecular compounds. Now we're going to look at ionic compounds. So in ionic compounds, the ionic compounds are formed when atoms transfer electrons, usually between a metal and a nonmetal. When an atom gains or loses electrons, it's no longer neutral and it becomes an ion. Okay, so you'll need your periodic table out for this part. Okay, and so there's a periodic table of element side, and then turn it over, there's a periodic table of ion side. So we're going to look up ions right now. Ion is just basically a charged atom. Okay, and so if you look up sodium at atomic number 11, you will see, and I'll write it down in here, that it says Na, and it has a plus. No number means it's automatically a +1 charge. Okay, and then oxide ion, look up oxygen atomic number 8, and you'll see that it says O with a 2- charge. Okay, and so that means each oxygen atom is negatively 2 charged once it becomes stable. Copper 2, if you look up copper, there's going to be copper 1 and copper 2, but copper 2 says Cu2+. And then sulfate ion, there's a tiny box up on top of your periodic table that says complex ions, and so sulfate is SO4, is the 1 sulfur and 4 oxygen atoms with a 2- charge. Let's go ahead and see how these ions are formed. So for sodium, the element, if you go to look up the numbers, right, you know that sodium is atomic number 11, so there's 11 protons, and you know that 11 protons means that it also has 11 electrons, so it's neutral, right? I don't know if you remember this, but for sodium, if we were drawing it, right, it has 11 electrons. It's got 2 in the first shell. It's got 8 in the second shell. 3, 4, 5, 6, 7, 8. And then in the third shell, it's got 1 electron. And in order for sodium to become stable, it has to have a full outer electron. So the question is, does it pick up 7 electrons, or is it easier to lose 1? So it loses 1 electron. So this electron is going to go flying off for it to become stable. Okay, you might see sparks coming off while it does that. So now what do we have? We still have 11 protons, but now, 11 minus 1 means we have 10 electrons. So what's plus 11 and minus 10? It's a +1 charge. Okay, so that's how we make sodium ion. And then let's look at chlorine. Chlorine is atomic number 17, so it's got 17 protons, but it also has 17 electrons. So if I'm going to draw what chlorine looks like, so I'll go chlorine. First shell has 2 electrons. Second shell can have 8, and I have 17 to place, so I'll go ahead and draw my 8 in here. And then I've got 7 electrons left for this last shell, so it's not going to fill up the last shell. 3, 4, 5, 6, 7. So the question is chlorine going to give away 7 electrons to become happy, or is it going to try and find an electron and pull it in? Well, it's going to be easier to pull in 1 electron than to give away 7. So it used to have, it had 17 protons, but now in order to become happy, you're going to add 1 more electron. So there is now 18 electrons. So plus 17 minus 18 gives you a -1 charge. And what do we know about opposites? Opposites attract. So you're probably wondering, where does this electron come from? Is it just floating around? Well, this electron that sodium kicks out is here, and then the chlorine pulls it in. And so if Na becomes plus and the Cl becomes minus, we know that opposites attract, and then it forms a compound. So here's a simplified version. The sodium gives its electron, and it goes into chlorine, and Na plus, Cl minus are opposite charges attract. So that's how ionic compounds form bonds, is they transfer electrons. Moleculars, they share electrons. Okay, and because they form charged ions, ionic compounds, if you dissolve them in water, they will conduct electricity. Okay, and so that's that part. Let's go ahead and look at how to write names of ionic compounds. It's pretty easy. You'll need your periodic table out in front of you. Ionic compounds, they're balanced by charge, so there's really only one possibility. So it's not like the other stuff, the stuff we looked at the other day. Carbon and oxygen can be carbon monoxide, carbon dioxide, carbon trioxide, 50 other versions of it as well. In ionic compounds, there's really only one version of it because it's balanced by charge. The naming is super easy. You write down step one. So if it's ionic, remember it's a metal and a non-metal put together, right? So the metal name, you just write down the metal name as it shows up. The non-metal name, you write down the name, but you change it to an I. Okay, that rules this way is similar to what we did with molecular. But here's where I said you have to be super active. Of course, there's no capitals in any of them. They're not proper names. And then that's it. But if there's three or more different elements together, right? Like CuSO4, I could see there's three capitals, right? There's a capital there, and there's a capital there, and there's a capital there. So that indicates that there's at least three elements or more put together. There is a complex. And the complex is almost always on the back side. And where are these complexes? They're in that little box in the periodic table up on top of the ionic side. Okay, and so you're going to have to be able to use that. So make sure you have your periodic table. You can't do any of this without a periodic table anymore. So let's try these lists together. So Na, you look it up, it's sodium. F is a non-metal, right? Metal first and non-metal, so you're always looking left and right side. F is fluorine, it becomes fluoride. And that's it. Okay. My favorite saying, along with drawing the symbol, is I. I don't use prefixes. Okay, and so no prefixes allowed with this. So Li, look it up on the left side. It's atomic number 3. It's lithium. Cl, that's C and an L, will be on the right side. It's atomic number 17. Chlorine becomes chloride. And no prefixes because it's ionic. I don't use prefixes. Next one, CaCl2. Capital C and A. So once you hit a new capital, you hit a new element. That means the C and the A go together. That's atomic number 20. That's calcium. Cl comes from chlorine. It becomes chloride. And that's it. No prefixes with that. If you call that calcium dichloride, it's very wrong. Okay? You're only allowed to use prefixes with molecular compounds, right? You've got that M sort of shape that you make with your hands, okay? And so M for molecular, and look, it's got like the numbers on your hand, so you know you can use prefixes for that one. But not this, it's just calcium chloride. Ionics do not use prefixes. Oh, look at this one. There is a capital and a capital and a capital, 3 capitals, which means the back end of that is a molecular. So Ca is calcium. And go to your little periodic table that's on top of your periodic table. SO4 is in, I'll tell you exactly where it is. SO4 is in the third column in the table of complex ions, third from the bottom. So it's like a mini periodic table on top of the periodic table of ions, and it says sulfate. So there it is, calcium sulfate. All right, here's where you would pause the video and you would try the following and test your knowledge. You would pause for a sec. Of course, I'm not going to pause because I'm teaching it. So the first one, CaI2, is calcium iodide. I don't use prefixes, so no prefixes. That Al is aluminum. O is oxide. No prefixes. That is not, like dialuminum trioxide. That's just crazy talk. It's aluminum oxide. Hey, look. 1, 2, 3 capitals. The back end is going to be my complex chart. So Ca is calcium. I go to my chart, the little periodic table on top of the table, and OH is in the second column, fourth from the bottom, and it says hydroxide. calcium hydroxide. Next one, Li is lithium. Br is bromine, becomes bromide. H is hydrogen. Cl, chlorine, becomes chloride. Ca, oh look, 3 capitals, 1, 2, 3. So the front side is calcium. I'm going to go to my little complex chart, the table on top of the table, and CO3 is in the first column, third from the bottom, it says carbonate. Carbonate. H, oh look, 3 capitals again. So the front part, hydrogen. The back part of it, I'm going to look up SO4. And SO4 is in the third column, third from the bottom, it says sulfate. CuCl and CuCl2. Well, the first one is copper 1 chloride. The second one is copper 2 chloride. Okay, because there's 2 versions of copper. So if you've ever wondered why I said copper 2 sulfate or cobalt 2 chloride, it's because there's 2 different versions of it. And I'll teach you how to pick out which one it is. Okay, we can try this one as well. BaI2, that's barium. And I comes from iodine, so it becomes iodide. And no prefixes because it's ionic, right? But SBr2, these are both nonmetals, right? So that's ionic. It's ionic, you need to know that. This one is, you know, it's molecular because it's all nonmetals. This is metal, nonmetal. So different rules, right? That one, no prefixes, right? I don't use prefixes. However, the molecular one must use prefixes. Like this is like an M for must prefix. So S is sulfur. Now, I'm not allowed to use mono on the front one, so that part hasn't changed. Br is bromine, it becomes bromide, that part is the same. Okay, but it's molecular, so I have to show that it's sulfur dibromide. So you can see, right? It's a very fine difference between them. So you have to, before you do any of these, figure out whether it's ionic or molecular. Before you can do any work. You always have to think about that first. Okay, and then I'm going to go ahead. You, of course, would stop the video and you would do these questions, and then you would check with the answer key to make sure you've got them right? Because there's no point in doing them all wrong. This is not for marks, but then there is an assignment that is for marks. So once again, this is ionic. It's ionic, and I don't use prefix. So no mono, di, tri, tetra. Just straight out. Make sure you're changing the second word bending. So like NaCl, Na is sodium, Cl is chlorine. It becomes chloride, and that's it. Right? Ba is barium. I is iodine. It becomes iodide, and that's it. No prefixes because, once again, I don't use prefixes. And same thing, MgO becomes magnesium oxide. Ca3N2 becomes calcium nitride. Do not use any prefixes. That would make it wrong because ionics do not use prefixes. Next one, it's a metal and non-metal. It's ionic. Ionic uses no prefixes, so zinc sulfide. Next one, it's ionic. It's a metal and a non-metal. Ionic, no prefixes. So it's francium phosphide. Oh, 3 capitals, which means that the back end of this is going to be in your little chart. So Na is sodium, OH is hydroxide. Same thing, 3 capitals, right? So K is potassium, CO3 is carbonate. Hey, same thing, 3 capitals, right? So He is silver, PO4 is phosphate. Next one's straightforward, hydrogen chloride. Oh, look, 3 capitals. So that's going to be hydrogen at the front, and NO3 is nitrate on the back side. Last one, AlF3, only 2 capitals, so it's aluminum and fluoride, and that is the end of writing ionic formulas. So there's a worksheet that's for marks, and then in the last next lesson, I'll tell you how to write formulas, which is really fun, but it's a little bit tougher.